This is the video introduction to experiment number 5 called Speaker Action. A speaker is an electromechanical device that was created to convert electrical impulses into sound waves. A speaker has a paper or plastic cone with a coil of wire wrapped around part of it. The coil in the speaker is placed in close proximity to a magnet such that when a variable current is flowing through the coil, the speaker cone moves back and forth. The movement of the speaker cone causes a vibration of air, which your ear senses as sound. Here is a picture of the front and back of a speaker. You can see the cone on one side and the magnet on the other side. You cannot see the coil because it's on the inside of the speaker. In this experiment, we are going to run a DC current through the coil, causing the speaker cone to move and stop. This movement will produce a click sound. Every time we connect or disconnect the circuit, it will produce a click. If we connect the speaker to variable voltages like music or speech coming from an audio amplifier, the speaker will create sound waves based on the electrical signal connected to it. In this experiment, you are going to assemble the circuit shown in the pictorial diagram on the upper right hand of this experiment page. The pictorial matches the circuit shown in the schematic diagram below it. Okay, this is the demonstration of the speaker in action experiment. What we're going to do is run current through the speaker and have it make a sound. The first thing I'm going to do is install the 10 ohm resistor. And according to the diagram, the 10 ohm resistor runs from 14 over to 24. So here's the 10 ohm resistor, a brown, black, black, gold. And you can see the color bands. And I'm going to run it from 14 over to 24. So if I look over here, it goes into 14 and then goes across to 24. All right, so now I have the resistor installed. The next one I'm going to install is the battery. And the battery snap actually goes from one side of the resistor to across the channel to another side, and that will then connect to the speaker. And then the next thing I'm going to do, now that I've got that plugged in, we'll plug in the speaker into this hole right here, which will connect it to the red of the battery snap. Now the other side of the speaker I'm not going to connect because that's the one I'm going to touch to the 10 ohm resistor to complete the circuit. And then what we're going to do is we're going to observe the cone moving. Remember I told you there's a coil in there and then there's a magnet. And when you run electricity, this is really quite an ingenious device. When you run electricity through the coil, then the magnet causes the cone to move. So let's connect up the battery and then we're going to try to observe it. Now you can put your finger on it lightly and you can feel the movement, okay? So you hear the click, and if you look at it real carefully, in this case, the cone is moving out and away from its position, its rest position. Now then, if I reverse the polarity of the battery by moving the battery snap and changing the red and the black, now when I touch and complete the circuit, makes the same sound, but in this case, if I look real carefully, the cone is moving toward the bottom of the speaker, goes in the opposite direction. Now that's what a speaker does, and when you hook it up to something that's varying like music or speech, then it moves the air and your ear senses that as sound. Okay, so we've demonstrated the speaker. I want you to do that. Wire up this experiment touch the speaker cone lightly and you can feel it move.